Hi everyone. Today I would be taking you through our experiences of doing cloud migration from on-prems to all of the major three cloud providers. And along with that, not only what are the pitfalls and the benefits of doing that, we might I would also try to discuss whether is it really necessary to migrate to cloud or not, right? With that, we'll do a quick go through of the reasons why we migrate to cloud, right? So basically, if you divide into two aspects of it basically comes along with the cost benefits and the technology benefits, right? So when we are talking about benefits, it reduces the capex spend. It increases the business agility. You can quickly change technology, and it enables digital transformation at much lower cost, because you basically have a plethora of technologies and the services which are already available to be used and eliminated at will, and there is no big spend, one time spend or investment going into it. And along with that, there is a large concern around maintaining the data centers. So that also goes away with that. And one major benefit is whenever we maintain our own data centers, we have to keep a lot of buffer in case of failures, and we need to manage our own disaster recovery and everything around that, right? High availability disaster recovery and anything, and which basically the in cloud, if we go migrate to major cloud, that is a huge benefit which we get out of this cloud, right? Along with that, from the technology standpoint, we can quickly move into the new technologies. It provides you a very scalable solutions. We can build very scalable solutions in today's world, and it provides a lot of security around our applications as well, because they are all industry grade security practices which are available in this all these major cloud providers. But having said that, the first thing which everyone we suggest, wherever we see, is that we have to see what is the end goal we are wanting to achieve by moving into this, by doing this cloud migration and by moving into the cloud. Is that is that goal cannot be achieved by staying on prem, or will that goal be actually achieved by moving the cloud of that particular application or that particular system without the organization having the view of moving everything together with it, right? So that is a very important bit which we need to take into consideration while moving into the cloud migration. I will give you an example. One of the systems which we are planning to migrate was an integration system, which was decided by the to be migrated into cloud, and we were chosen as the chosen partners of it. And the aim of moving the cloud was that the systems was not scalable. The system had some capacity issues, and it was assumed that once we move into the cloud, those issues will go off immediately, right? But when we started this due diligence phase of the system, what we realized is the system itself, or the underlying infrastructure, the issues are not with the underlying infrastructure itself. The issues were how the code were written, what are the patterns being used in the code, which due to which all these issues were the bottleneck of the issues. And the plan migration was to take all of this into cloud. Cloud became, because of its scalability, will hide the issues for you, but that will like increase the cloud bill that um, at that scale itself, right? Because if you are taking something which is not performant, and so what it will do is it will demand more and more infrastructure and resources to run. And as you do that, the cloud bills will keep on increasing, and at the end of the time you realize that the benefits which you were wanting to reach in the cloud will is coming at a huge cost, which was promised, that won't be there, right? So what we started with was having a look into how we can refactor the application, and whether after refactoring the application, can we achieve the end goal of the application being staying on prem, because the northbound and the southbound system of this integration platform were already on prem, and because of security reason they didn't have any plans to move to the cloud anytime future, right? So that's what we ended up doing in reality, that the system was completely refactored and the patterns rewritten, and we made the system cloud native but still running on prem, so that the egress and ingress cost could also be saved and all the capacity issues were also resolved. In the stark contrast, we have also done a lot of migration into cloud, which has given a lot of benefits to the customer. So one of the customer was running one of the typical integration system name Oracle service was on cloud, sorry, on prem, and they had 100 plus VMs to run this application because they wanted the systems to be always highly available, right? So they were having server resilience on in the same geographical location, and then they were having cross geographical resilience as well. So in that, the overall infrastructure requirement was huge, and they were spending. They had already spent a huge capex cost and spending huge opex cost of not only the systems but also on the infrastructure and data centers as well. And when we started migrating the system into microservices and start pitching small parts of the systems out, what we realized is just by migrating a subset of the application, we would decrease the infrastructure requirement by 30% of what it is. So 70% saving of infrastructure was immediate, right? So only by migrating the top 5% of the services in the cloud and rewriting in the cloud native way, we saved a lot of infrastructure cost, and the entire migration cost and the cloud cost was only retrieved even itself by first year of savings of the data center in the infrastructure opex cost. So those are the decisions which we have to think about while migrating the cloud. And very important thing while migrating to the cloud is to consider what is the savings you are going to have on on-prem and what is the cost you are going to incur every year on the cloud services, and then optimize those cloud services. With those, then there are multiple cloud migration choices which we can have, but I have tried to divide it into three major bits, right? So one is the rehost, the first one. So it's very straightforward. What you do is you treat cloud as another machine, but you take everything from your on-prem and keep as is on cloud, and you use cloud EC2 instances, storage, networking, and all the benefits of cloud. And you can have, we can also use something, all the cloud features like scalability or auto scaling groups and all those to have all the cloud benefit, but underlying systems don't change at all. So the entire application is picked up as is and moved to cloud, right? So that is the rehost, and there are a lot of benefits of doing that. Along with that, that also has some pitfalls because your application is not really cloud native. So a lot of benefits of the cloud could not be realized in there, and the immediate benefits could be that in this you, if for example, most what we have seen is, in our migration cases, there would be systems which will be just holding on the data center and not moving along because this could not be refactored, or they are too old to be refactored and should be replaced in this next couple of years with a newer system which is getting built. And this, because of this system, the entire migration is blocked into the cloud, right? So in those cases, this rehosting provides a greater promise. So because you can do it in a very lower cost than re-architecting and refactoring the whole application. So that is one way of doing it, right? Re-hosting means just lift and shift. The second one is re-platform. What basically it does is, it is similar to rehost, but what we do is we take the core system which doesn't have that way, because it also is a saying, right, that uh, the thing we should not touch, which is a vehicle which is running perfectly, right? We should not go and tinker with that at all. So that this reflect platform even comes from that thinking as well, that the core systems which are working as is and they are, so let's not touch that. But what we do is we create ancillary services around it, so that this system, core system, can now be integrated with other systems. Like we expose APIs for that, we create event driven systems around it, so the core architecture remains the same, but we create ancillary applications for it and modify some part of the application so that other systems can interact with it in the cloud native way, right? So that is re-platform. And refactoring is basically redesigning and re-architecting all the components of the whole application. This starts from re-architecting the system from scratch, we start thinking what the cloud native applications would look like. We have certain principles like 12 factor app principles. We align to that. In we have an ideals principle which we follow in Tori Harris very frequently, which basically talks about how your cloud native application should look like. And and we have an maturity model as well. So what we do is we get an application, we do a maturity scoring of it at how cloud native it is, and based on that we start refactoring the application. So after refactoring, we see where what is the maturity level we have reached around it. So there is a scoring system and everything around that. And when we say refactor, it's cloud agnostic and cloud native. Like you can put in any cloud systems or in prem, but and it doesn't matter where you are running it basically. So these are the cloud migration choices which we can based on our we have to do a study of our system and our need for it, and based on that we can choose those. Then basically there are certain phases of cloud migration. Once we have decided, right, that we have moved to the cloud, so this is the stage where we say that should we move to the cloud or not, where what we will gain and what we lose. This is a very important phase, because what happens is many a times we have come in the later stages of the application, which we say in the migration phase or during launch phase, we suddenly realize, oh, our on-prem was better, and people have contacted and seeing what has gone wrong, because at that time those considerations were not made, and that acceptance criteria of moving to the cloud was not clearly defined, right? So this is very important step to have. After this is done, this is basically in any migration stage, these are the generic points, but what we do is it is customizable as well based on what the workload is and what we are migrating. So we assess the current system, we plan the strategy, we creates of the HLD document, how the networking would look like, what the migration approach would follow, how the other system would behave after this migration, and what are the integration points they have, and how do we how those systems have to be changed if necessary, or we normally try to have the least impact on other systems. So that is all decided in this strategy planning stage, right? So basically, once we are done with the strategy, then we have to start preparing the environment, data, and environment and people, right? So these are the three things which we have to do it in parallel. When we are talking about data, it's the what is the data migration of this application would look like, what will be the cutover point, and when the parallel data insertion will happen. So this is typically achieved by a migration controller in between. There are different strategies by which we use it, something like we have strangler patterns, strangler and fig pattern, and all those patterns are available, which using which we decide that how the data flow would happen during the migration phase and post migration phase. And during that we also think about what is our rollback plan would look like, and what will the impact of data on the rollback plan would have. So all those things are decided here, right? And along with that we have to be ready with environments. When I said environments, is very important to understand that um, as the base, our cloud should be created completely through infrastructure as a code, right? This is the strong belief we have, because what that enables us to do is to at will create and destroy the environment within seconds, right? And not to have the configuration issues or something getting missed out when we move along environments. So this is very critical to us. And what we normally suggest to the clients, and we practice in all our projects, is we normally disable anything creating from the UI screen, right? So in many projects we use git based approach, where anything change in git, we as the code infrastructure is also created from git as well itself, right? So the and along with that is people. What we have realized when we started with this journey of cloud migration for multiple clients is that we still think cloud as on-prem. All our strategies of having, say, typical example is creating active setup, right? In creating an active setup in a cloud and on-prem is vastly different. Load balancing is different. How would you balance across clusters? How would you basically do your DR? How you do your HA, right? So those has to be embedded into our thought process as well, and we have to think about it as a distributed system and utilize a lot of what cloud provides, right? And in this there are a lot of frameworks available, like AWS well architected framework. GCP has its own cloud migration principle. Azure has their architecture principle. So whichever cloud you are having, then those all this principle are cloud agnostic. So you can use AWS well architect framework on Azure as well, right? Because they are principles and guidelines. So those become very important for all the people to understand, and also for our architecture and the designs to happen in that way, right? Once this is done, what we start doing is coding, and during that what we do is you normally use the test driven development approach, where we start doing our writing our test, and basically we start our developing our application, validating our application against the test, and this all mostly happens in our DevOps pipelines, right? Everything is embedded in our DevOps pipeline. It's all Git driven and everything. And then we finally executing our migration phase, where I talked about what the parallel run would look like, what our how would we have our data migration being happening during the parallel run, how do we do the data synchronization and everything. And once we are and in this also comes the different models as well, deployment models as well, like canary deployment, blue green deployment, A/B testing. Based on our need, we have to think about all that and create an approach for it, right? Once this is all done, we retire our on-prem application, which is very important. Make sure this all the servers are shut down. We recover whatever the capex we have spent, or hand over to the right team which does that for you, and then launch the application on cloud, right? These are the different phases and process of a cloud migration which we have to do. And in that, I have not mentioned security as a separate phase, because security cuts across all the phases, right? When we are cloud, we have to be also be very careful that one misconfiguration in VPC can make our cloud public, all our APIs public, all our data public. So we have to be very careful about our security, and security has to be shift left from our infrastructure creation, design, architecture, everything. And we have to shift left to them very we should not think about security at the end of the during the launch time, but during our design, architecture, creating the infrastructure, designing our code, writing our code, everything embedded in security. And security, our DevSecOps pipeline should have security embedded in it. Say all the security checks embedded in it. May it be licensing check, may it be vulnerability check, or may it be best practices and everything. So there are various tools nowadays to do that, and we can very easily embed them all in our DevSecOps pipeline. So yeah. So basically, this slide talks about the same thing which I was discussing on the previous one. But what we have tried to do is, on each phases, what are the different things we have to think about, so that we don't miss anything, right? So once we have to define the new application and existing application, we need to create the architecture for it, which involves the architecture assessment, validating the application, and selecting the components which needs to be migrated, or whether we need to do a lift and shift or refactorize. So everything happens in this. Develop phase talks about all the three different approaches I talked about. And this here we do development, testing, and validation of the application. Everything needs to be automated. Everything, basically the testing, so we do CI, CD, and CT together. And the optimization and security are these are the two principles which have to be ongoing always in cloud, right? Because cloud, if you use based on the services you use, but you pay for every second, every minute of using that services, right? So lot of things comes in cost optimization. Like for example, I will give you a classic example, right? With some mathematics around it. Say you have a test environment, right? And on-prem, we always have to have like always running test environments. But if we take the stats out of it and think about who really tests the environments during what times, right? And we plotted a graph against it. What we found out was that most of the testing happens during an a 12-hour window of the daytime, right? On the weekdays. So we plotted, and then we found out that around out of that around 8 hours, and this is the numbers might vary. We have done a lot number of such migration, but the stats come out something similar. Some 12 might become 10, or 10 12 might become 14, but then something, the range is similar, right? And we found out around 10 hours no testing happens at night. We call it graveyard shift, right? No one does anything, especially because the developers and testers on test environments don't work during nights mostly. So what we do is we have to have approaches like that. So what we do is, if you do a simple math, right? So 12 hours of testing which happens, and we keep our application. So in a month there are 720 hours, right? And say only 12-hour testing happens, and normally we work on a 5-day working week, and on an average we work for 22 days, right? So 22 into, sorry, 22 into 12, if we do, it comes around 260 hours, right? And say you add around 20 or 30 hours based on the worst case scenarios more to it, so you would see that your total working hours would come around 300 hours. So now if you see, out of the 720 hours which you would have paid for, if you have a smart way of shutting down our application, bringing your application back up again within seconds, which cloud provides you to do, you would basically be saving more than half the cost of your cloud instances. This is only for test. For example, in dev environments, what we in any project which I particular move in, what we do is we create dev as preview environments. What that it means is that, in if a developer has deployed something and he wants to test it, this would be running only till the 6 hours of deployment, and post that it gets automatically deleted. Okay, till developer puts a flag in saying that, okay, I need it for a longer hour during a CI/CD pipeline trigger, right? And if it is longer also, at midnight it shut down again, because developers normally would want to test immediately, but what happens is, in they keep things running and no one ever shuts them down, right? Till there is some audit happen. So we automatically shut it down. And next time they have to do it, they can trigger the CI/CD pipeline again, which doesn't take more than 30 seconds to deploy. And they would have everything up and running again to test it for another 6 hours. So that saves a lot of cost, because in cloud, the cost for dev and prod is not different. Sorry, not same. They are exactly the same cost which you are going to pay. So put as much optimization of cost which you can do it in your lower environments, and production is based on how much you can do. If you want, you have auto scaling enabled, that's great. You can auto scale down. You can have warm up scripts in the morning to bring things up way before your main day starts, and all those things will involve in FinOps, right? Along with that, security is important. I've already talked about it. And another thing is observability and lean ops. So when we talk about lean ops, lot of auto remediation, corrective actions, and everything has to happen during the design phase and your application build itself, so that we can achieve all of this in the production. So we don't sit with that big of an L2 and L3 team to look into, or L1 team to look into all the issues which has happened. The system should have the auto remediation capabilities, and also very important to have is, in auto remediation, all the things which went wrong had to be captured, because auto remediation or corrective action of a service when it goes down is just an way of not failing things and bringing things up again very fast, but it doesn't solve the underlying problem. So to solve underlying problems, you should have all the all the stats and all the error logs and all the heap dumps in a Java world. When if you have an out of memory, everything captured, so that when someone's look at this problem, they should be able to fix it, so that auto remediation doesn't trigger. So our aim is to not trigger auto remediation, okay? But it is just an helping tool for us. And similarly, we have to look at the metrics. So red. So we have four golden signals. We have red methodology, use methodology. So we have to see what fits best for us, and then we have to basically start monitoring and everything around that, right? And This is basically the phases which we have to talk about. We discussed about a lot of things, but I feel that couple of things I will talk about it here. So post-mortem culture, so as I talked about, we have to build the post blameless post-mortem culture when we are moving into cloud, because we are all learning together, and that really brings out the all the ideas from the team, and basically people own up to it instead of passing the ball of to someone else, right? So from the postmortem culture, it comes to continuous improvement, right? So basically, when I talked about the auto remediation, system should recover automatically, but we have to aim that this situation doesn't come at all. So, right. So all those things have to be done during our define phase itself. And basically, one other very important bit is that our is basically when we are designing our systems, we always suggest that you have to design and define your system in such a way that it's not tied to a single cloud. When we are talking cloud native, it should be your core components which you are spending the most time building or most time designing and implementing should be cloud agnostic. Because if the tomorrow it need rises, it should not happen that you need to run another whole project to move from say AWS to Azure, right? So that is also very important while doing it, right? So yeah. And with that, I would come to standard tooling. I have used here a very basic CI/CD pipeline. Look, with this, I have not talked about test lot of testing approaches like API fuzzing, static application security testing or dynamic application security testing and everything around it, because we feel that DevOps is something which matures over time, right? You have to start small, you have to have the basic thing right, and then start maturing your system more and more to achieve the independence of the manual work in your pipeline itself. So this is the very basic pipeline where we start with the planning stage in Jira. We code it into Git. We review our code using Sonar Cube, push all our artifacts into Nexus IQ, build using Maven, use multiple testing tool. We have a lot of automation frameworks created based for UIs, for APIs, for services and everything around. We monitor our services using Prometheus and Graph9, operate, deploy on Kubernetes, do the configuration management using Ansible, store the secrets in Vault, and basically tie all of them together to Jenkins. All of these tools which I mentioned here are replaceable. In today's world, to be very honest, each one has 100 other alternatives with 100 other features, but very basic is to imbibe the CI/CD um, culture, the continuous DevOps culture within your teams, and the tooling comes second. Tooling is based on the underlying framework you are using. It a lot of time depends on what the organization using in other projects and whether the licenses have been already been bought. But more or less, these are the very basic CI/CD tooling framework which we are talking about here, right? Yep. And this is basically uh, a very generic one which we did it for, but there are some examples of some one basically migration we did for an API system from one of the on-prem AP self created APIC platform to APGX. So basically this talks about that example. So what we do is we take one brick at a time. We take the smallest bit, we migrate it, we monitor and stabilize the system. We see that everything is created, is there. So we what normally we do is we see what are the different patterns or models of the applications which are there. We try to do one each, so we know instead of doing the whole application together, we took the smallest pieces of it in the start, and then monitor and stabilize it over time. We, as I said earlier as well, we have to have the rollback plan always ready, because it's not might be our problem, it might be our neighbor, or the northbound or the southbound system might have a problem, and because of that we need to go back within time. So the business shouldn't stop, so we should have a detailed plan to reversing the traffic on prem and reversing the traffic to the existing systems, right? And it should not, we need to have a detailed plan, and not only of the process of of the tooling, or the technical process of migrating back the traffic, but also it's very important to have the people process defined as well. Who will be the decision maker when this decision has to be taken? Whose approvals are required? At what point of time, at what point of failures, or what point of time we will migrate, do this migration, so the decision could be quicker. Because many a times what happens is we have a great rollback plan, technically, but the decision of whether rollback or not takes a lot of time, and then we end up having a lot more failures than we would have, right? And then we start adding consumer and more APIs, and repeats the process whole thing. And in here we call it DSMR pattern, which is basically deploy, stabilize, monitor, and repeat. And that in the pattern itself we have blue green model and A/B testing and whatever supports. In here we try to achieve all that there. This is just an a random, it's a very, this is a timeline of migrating a complete digital state, which we have done. We could not tell you what the state was, but it was, if I would say, it was supporting around 1800 TPS traffic. It was a complete system, which was starting with the CRM, and all the digital channels in the front end integration system, and then the billing revenue system, and also your orchestration system and everything involved, right? The whole piece. And we achieved this migration in 12 months. And as I said, this basically defines the timelines of what, if you want to do migration of that scale, what it looks like. But it could be synced further if the application is small and we want a lot of more parallelism, or we can drag it also if we want more stability and we want to see what it is just an example. So basically, we normally have a very long define phase and pre-migration phase, because everything we try to sort it out. Then we, all the edge cases, we try to figure it out. We do all the POCs there. We do dry runs of some extent there of the POCs done, and all this in the pre-migration phase, right? So we define and develop into the first 6 months. So we, and then what we do is we automate and deploy. So in, if you see here, the automate, post, all the three stages are run in parallel, because what happens is you start, we with DSMR principle, which we do, we deploy one at a time. So these things happen in loop. So we deploy the services, we optimize it, not only from the performance perspective, from the cost perspective and everything, and we secure the application and we keep monitoring it. We have the confidence, we repeat the process again and again. Typically, we, in this migration, we were at a time doing migrations of each, putting everything in production one, each every day, and we would monitor the next day for the traffic profile and just migrate the 100% of the traffic there, and then repeat, and then we will able to achieve this timelines in that migration, right? So this is the typical timelines which you can think of while doing this cloud native migration. And this is one of the use case. I have a lot of other use case, but this is one of the critical ones, interesting ones, which is basically we did. So what we figured out was, we had to migrate an ESB upgrade for one of our clients, where we have to migrate to 11G to 12C of Oracle Service Bus. But the aim was to migrate those application into a cloud native way, right? And but we had both the constraints of timelines and budget, because 11G, particularly, was going out of out of support. So what we started doing was that, we tried to find out what are the services which we, when we migrate into microservices in the cloud native way, would give the biggest benefit into the client, to the system altogether, and the system stability. What we figured out was that most of the services which has the huge traffic were the T2R services, postal services. And we found out that they were latency sensitive, because they were being queried through apps, through webs, and when the agents would have the call. So we figured out those services, and the subset of those services we found out would create would have basically 50% transaction itself. So we were able to take off the 50% traffic on there, and onto microservices, and it not only basically created a lot of capacity benefits on the existing infrastructure and the to be infrastructure, but it also gave the pathway of migrating those next set of services and achieve further benefits of it. So this is one of the example, and along with that we created a lot of tools around that so that we can validate the systems and everything around that. So this is one of the example. There are a lot of other examples as well, but I think we will send the slides out and you can have a read through it. So that is basically all from my side. Thank you all.